Okay. Today I'm going to show you how to build a Doug coil. Uh, Electromagnetic pulse frequency adjustable electromagnetic pulse generator. Um, this is my DDS function generator. It's basically, yeah, I had to read that. This is my DDS function generator. It creates arbitrary waveforms at variable frequencies. Frequency range on this particular one is anywhere from 1 hertz to 1,000,000 hertz, and it does them in square wave, triangle wave, sawtooth, and sine wave. So it's a pretty handy little thing. And what I have it hooked up to is I have it hooked up to my stereo amplifier, so I can increase the voltage coming out of my synthesizer here, my frequency generator. And I just have it connected to one here because I don't want to get the frequency messed up, so I'm just running it into the one because it's a mono stereo anyway. The output will be just one. If I was using a different system, I would bridge the two, but I'm not doing that. So I just have it hooked up to one. I have it coming into the input on my stereo, or on this amplifier. It's a Fender 35-watt amplifier. It's an old one, but it works. And basically what I did was I disconnected the speaker from the back, I hooked it up to a pair of wires, and I have it coming out to the rest of my Doug coil machine. As we're going to turn our voltage meter on just to see what kind of volts we're getting off the back of this setup here through this connection. Basically the voltage meter is hooked up to these capacitors here. We come out of one side of the back of the speaker and we go through a series of ceramic capacitors. The reason we triple these up like this is because these are each 7 watts. That's it. These are 7-watt resistors, and the back of this stereo can put out about 38 watts. So we don't want to wreck these resistors because I don't know, they're a couple bucks each or something. So, and then basically we have our voltage meter hooked up right here. Our voltage meter is just hooked up to one side of the resistors, goes through the resistors, and then to the other side of the resistors, and that's just to check the voltage in the system. And in this entire system back here has that much voltage because it's hooked in series. So and then on the outside, okay, from there we have it going out to our capacitors. We have 3 different types of capacitors set up over here. We have a 270 volt alternating current capacitor from a microwave. It actually has 2 separate capacitors in it. The capacitance rating on that is there's a 45 microfarad capacitor and there is a 12 microfarad capacitor. So then we have it running out of our capacitors and into one side of the coil. Basically it goes into one side of the coil, it goes all the way around the coil, and then the way it does is go right back to the other line that connects right back into where I disconnected the speaker from. And that's how easy it is to put it up. It's just a series of resistors, or a stack of resistors. So these are parallel resistors. I have them, they're in parallel to increase the wattage that they can take. Then we have it hooked up through our, there's another capacitor here. This other capacitor is a 2.2 microfarad capacitor. And then I also have a 1 volt, or a 1 microfarad capacitor. If I'm using a reasonably low frequency, so I want my capacitance on these to be fairly high. 45 is a bit high, but for running these low frequencies, it should be just fine. Now I'm going to turn the system on here. So I've already turned my, well, okay, yeah, there. I turned my frequency generator on, and I'll let you see that. You can see it's at a square wave. at 432 Hertz. I have the amplitude set to about halfway, and we are going to turn the system Okay, there we go. And we turned it on. We're going to increase the amplitude on this guy a little bit. And then we're going to go over to our input on our stereo as we increase the volume on the stereo. The voltage on the back of the system will increase. Right now we're at about 3.2 volts. We can get it up to 4 if I mess a little bit, but 3.2 is good for now. So that's 3.2 volts of alternating current on a square wave pulse or square wave frequency at 432 cycles per second. So we are pulsing this coil of copper at 432 cycles per second, creating an electromagnetic field that flops in and out of basically this 3D rendition of an electromagnetic field here. So in this area that it takes up, this ether here, it's pulsing in and out of that at 432 cycles per second. And it can float through my hand. It can, the electromagnetic pulse can pass through other objects. So you want to keep it away from any of this stuff. You want to keep it a reasonable distance away from your voltage meters, from your amplifiers, and from your frequency generator. Because if you don't, the electromagnetic field generated from that has the potential to mess with some of your other equipments and completely destroy some of your ICs and some of your transistors. So that is my rendition of how to make a Doug coil. Right.